we are going to see the lecture number 48, comparison of excitations under equivalent circuit phasor diagram of synchronous motor. Okay, comparison of excitations. First topic. Comparison of excitations. So here the first column, type of excitation. Okay. Second column, comparison of E and V. E will be the back EMF and V will be the terminal voltage. And third column is nature of power factor. Fourth one, it is armature current, IA. Okay. Now first, type of excitation. Okay. So generally the types will be classified into four types of excitation. The first one will be normal excitation. The first one is normal excitation. So in normal excitation, what is the relation between E and V? In normal, E equal to V. This is normal excitation, and the nature of power factor will be lagging. Armature current IA will be increased. Okay, during normal excitation. Second one, under excitation. In under excitation, E is less than V. The nature of power factor will be lagging, and the armature current IA will be increased. Third point, over excitation. In over excitation, E will be greater than V. The nature of power factor will be leading, and this armature current IA will be increased. Fourth point, critical excitation. In critical excitation, E will be greater than V. The nature of power factor will be unity, and the armature current is minimum. Okay, so this is the comparison table of the different types of excitation. Comparison table of different types of excitation. This is serial number. Okay, this is one 3 mark or 4 mark question. Okay, now the next topic I'm going to explain how to draw the equivalent circuit of synchronous motor. The next topic will be equivalent circuit of synchronous motor. So you are very familiar about the synchronous motor principle of operation. So this is the diagram of synchronous motor structure. You see there are two winding structures are available. One is stator carries stator winding, or the other name of stator winding is armature winding. Okay, so in armature winding only you are giving three-phase supply. Are you understand? So this is my three-phase supply which you are given to stator, and inside there will be a rotor. You see here, this is a rotor, and in the rotor there will be a windings are there. You see, this is a winding. Okay, so this winding will be excited by DC supply, okay, which is excited by DC supply. So there are two windings are there. As well as the synchronous motor is not self-starting motor, so to make the motor to self-start, so we have to introduce a damper winding arrangement which is to be connected in series with it, or it will be called as additional winding arrangement in stator. Okay, in stator we have to add additional winding in the stator. Now by using this both stator and rotor field winding structure, I am going to draw a equivalent circuit diagram. So how to draw? Okay, now I am going to explain step by step procedure. Please listen carefully. Who is this fellow? Somebody is disturbing the class. Okay. Now, in stator side, this is stator. Okay, now I am drawing the stator winding. In stator there will be a winding structure will be there. You see here, plus, minus, sinusoidal supply. Okay, it is a AC supply. The instruction is applicable to all the students. Okay, it's not applicable only to the some group of students. Everybody should take the responsibility. The keynote persons are the role model to every students. They should not disturb the class in between. So here in stator there will be a resistance. This is the resistance. Armature resistance. RA. RA stands for armature resistance. Okay. And because we know in stator, you see here, this is a slot. Okay. This slot is nothing but it is the winding. It will be look like this. Okay. This is nothing but a coil. Okay. So this coil is having a resistance and a reactance. Okay. So this part only I am drawing here. Are you understand? So resistance. RA stands for armature resistance. So the resistance connected in the armature, that is nothing but stator side, we have to call armature resistance. Then it is joined. Then it is having the reactance term is also B. So this reactance will be XL. Leakage reactance. XL. I understand. Now to make the machine to start, so we need an additional winding here. That is nothing but damper winding arrangement. So this damper winding arrangement I marked as in different color. This is nothing but XS. XS stands for synchronous reactance. XS stands for synchronous reactance. So the combination of XL and XS is nothing but XS. Sorry, this one will be armature reactance, XA. Okay, XL stands for leakage reactance, XA stands for armature reactance. I understand. Then it is connected with E plus minus. Then join. Okay, so note down RA will be armature resistance in ohm. XL leakage reactance in ohm. XA armature reactance in ohm. Okay, and this E nothing but excitation voltage, or we can say it will be a back EMF also. Excitation voltage in volt. Then XS it will be a synchronous reactance in ohm, that is X S is equal to XL plus XA. Okay, so the combination of resistance and reactance, we can write impedance. Impedance Z equal to Ra plus Xs. Okay, because it will be Xs with nothing but reactance term, it will be having an imaginary part, Ra plus Jxs, or we can write Z equal to square root of Ra square plus Xs square, Ra square plus Xs square. So this portion is nothing but stator. Okay, this portion is nothing but left hand side is nothing but stator. Okay, and one more, the current flowing here will be I. It will be called as armature current also, we can write. I is nothing but a current. Then inside you see there will be a field winding. So for field winding, what I am going to do, this is nothing but field winding. This winding. This winding structure. Okay, so I mark it in this color, pink color. Then you can mention this is field winding. Field winding. Where it is connected, this structure is nothing but, sorry, this structure rotor, right? So this field winding we can write called or rotor winding. Okay, rotor winding. And where it is connected, it is connected with the DC supply, minus plus, and this one will be DC supply source, DC supply source. Then positive terminal, it is connected with a rheostat. Rheostat means you have to adjust this DC excitation. So for that I need a rheostat. This is my rheostat. Okay, so the rheostat connected in field winding, so we have to call it field rheostat. this field rheostat will be variable. Okay, this RMR is called as variable rheostat. Then the current flowing from this DC supply, which I am mentioning here, IDC, this one, IDC only entering into the rotor. So left hand side will be a stator, right hand side part it is the rotor. Left hand side is stator, right hand side is the rotor. So this diagram is nothing but equivalent circuit of synchronous motor. Equivalent circuit of synchronous motor. Now here, what is the relationship between V and E? So we can write E equal to V plus I into Zs. I into Zs. So therefore I equal to E minus V divided by Zs. This is for excitation voltage per phase. Okay, suppose you are excited, this equation is for excitation voltage. Voltage per phase. Suppose if excitation voltage is reversed, voltage per phase is reversed, what happened to my equation? So this, instead of E, I can write minus E equal to V, and if I change this E term, the current will be changing. So minus I into Zs. Okay. So if I change the terminal voltage, that is excitation voltage, terminal positive, negative, if I change it, I can get the symbol negative minus E, and this will affect my current also, minus I. Okay. So therefore, and what happened? The current. Therefore, I equal to V plus E by Zs. The combination of V plus E is nothing but resultant voltage, ER by Zs. ER by Zs, where ER is the resultant voltage. Okay. Now here in the above equation I have done a mistake. Here you see, here when excitation voltage per phase will be positive, so during this time the voltage will be minus V, because we know the basic equation V equal to E plus I Zs. Okay. So from this I can write E equal to V minus I into Zs. So instead of this minus, you can put E equal to V minus I into Zs, or we can write, better I can write it like this, directly I can write, then you can understand. Now excitation voltage per phase V equal to minus E plus I into Zs. Okay, where Izs will be the impedance drop in the winding. Okay, impedance drop in the winding. V is applied voltage, E is a counter EMF, or we can say it will be a back EMF or excitation voltage per phase. Excitation voltage per phase. Any doubts? Any doubts here? Where the effect of stator magnetic field is nothing but your synchronous reactance Xs. Okay, Xs will be the synchronous reactance. Any clarifications? Any doubts? Or understand this equivalent circuit diagram? Or understand this equivalent circuit diagram? Any doubts? Any doubts, students?
Sir, that V is equal to minus E plus I Z, sir.
V equal to
Minus E plus I Z, sir.
yeah, minus E. That is the basic equation as V equal to E yeah, V equal to E plus I into Z. Okay, this is my basic equation. But what happened in the synchronous motor, this E term you see, this is negative. The reason is that here we are having the winding arrangement. It is not the winding which is having in the induction motor. The winding structure, it is entirely different in the synchronous motor, so which creates a back EMF in the negative region, that is minus E, because the motor will start rotating. First starting stage it starts rotating reverse, then it starts moving forward. Okay, so that is what you are getting minus E, otherwise we will get plus E only. Okay, in DC motors we will get this equation V equal to E plus Iz. Okay, this in DC motors it will be like that, but in synchronous motor we are getting minus E term. Are you understand this difference? Are you understand or not?
Yes, sir.
Okay, here I can write minus E plus I into Zs. 1 second student, please wait. Madam, மேடம், வினய் கூப்பிடுறாரு மேடம், கிளாஸ்ல இருக்கேன், நீங்க என்னன்றது பேசுங்களேன். வினய் வினய்
You can tell students to wait for 5 minutes now, sir. Hello, Vinay sir, I am Gunapriya. Sir is calling. Hello, sir, I am Gunapriya, sir.
Are you understand? Any doubts?
Sir,
This is a basic equation of equivalent circuit. This is one 5-mark question. Okay.
sir,